Now we're going to look at some ideal gas law problems where we also have to use molar mass to convert between grams and moles of a gas. Take this problem, for instance. Calculate the volume that 12.5 grams of CO2 gas will occupy at a temperature of 40 degrees Celsius and a pressure of 1.0 atm. I've gone ahead and filled in a number of the variables that we're going to be using. As you can see here, volume is what we're going to be solving for. When we do this, the first thing that I always check is to make sure that the units of the variables match the units on R. Okay, so we have atm, that's great. Temperature, as you know, needs to be in Kelvin to work with gases. So I've gone ahead and already done that because I'm sure you guys are probably familiar with how we add 273 to the degrees Celsius to get Kelvin. So I'm going to change 40 degrees Celsius here to 313 Kelvin. The next thing that we have to do, though, is look here at the amount of gas we have, N. Right now, it's reported in grams, 12.5 grams. But to use it in the ideal gas law, it needs to be in moles. So this means that we're going to have to use the molar mass of CO2 to convert from grams of CO2 into moles of CO2. So the first thing we have to do is determine the molar mass of carbon dioxide. Well, it has 1 carbon and 2 oxygens. So we take the mass of carbon plus 2 times the mass of oxygen, add these together, and it gives us 44.0 grams for each mole. All right? So now what we're going to do is we're going to take 12.5 grams of CO2 times, I want to cancel out grams, so I'm going to flip this fraction. 1 mole divided by 44.0 grams. And the math that I'm going to do is 12.5 times 1 divided by 44. I'm going to round that to 3 significant figures. 1 mole, this is an exact counting number. So we don't worry about significant figures for this. 3 here, 3 here. So I'm going to round this to 3 significant figures, and I'm going to get 0.284 moles of CO2. So we can cancel out grams and show that we've changed this into 0.284 moles. Now, everything that I have in terms of my variables matches with a value that I have on R. So I'm going to take PV equals nRT, the ideal gas law, and calculate and rearrange this to get V by itself. So all I have to do is divide both sides by P, then the P's cancel out, and I get V equals nRT divided by P. So I've gone ahead and plugged most of these values into the equation. I have N, I have T, and I have P as before. I leave R until the end, and here it is. Now let's go and cancel the units. ATM's here, ATM's up here, moles here, Kelvin there, which leaves me with liters, which makes sense since I'm solving for volume. Now the math I'm going to do this times this times this all together, then divided by 1.20 atm. And I'm going to get 6.08169. How many significant figures do I round it to? I round it to 3. So I keep the 6, I keep the 0, and I keep the 8. And I look whether I round it up or down. I keep it the same. So I do, my final answer is going to be 6.08. What are my units? The units are what I was left with after canceling, 6.08 liters. And that's my final answer for this.